developers from every corner of the world, all at one place. 29th of April to the 5th of May 2023 at SCB10X, District X, Bangkok. Let's innovate, create, and revolutionize blockchain for the next billion users under the theme of blockchain for the next billion users. Financial innovation, gaming and metaverse building blocks, social network and decentralized society, real world use case. Meet our global partners. Win the prizes. First prize $10,000, second prize $5,000, third prize $3,000, and incubation and mentorship opportunities special for overseas participants. Free flights up to $1,000 per person. Free accommodation during the 28th of April until the 6th of May. Powered by Fraser Property and Moderna Hotel Residences. Apply now until the 9th of April 2023 at www.scb10x.com. Let's leave our mark on the world.
All right, let's get started. Yeah, so good evening, everyone, and welcome to our meetup. Glad to see a few familiar faces as well. Glad to see new ones. Welcome to SCB10X and also District X overall. Before we get started, I wanted to do a quick recap about the video that we just saw about the Bangkok Blackathon 2023. So this is a 7-day event that's hosted at District X during April 29 to May 5th for developers, builders, and entrepreneurs. This hackathon is open for those who are creating or building blockchain projects. And the areas of focus that we are looking to do in this blockathon includes financial innovation, gaming, metaverse building, social networks, and decentralized societies. Anything to build the next billion users. We will offer $18,000 in prizes and opportunity for incubation, mentorship by SCB10X, and partners for blockchain-driven products. The final deadline for this application is on April 9th. So please feel the urgency to apply to our campaign. Now, getting back to the Moonshot meetup, this meetup is a platform where innovation, technology, and ideas converge to shape the future through a networking event. Pan and I will be moderators for you this evening, and we are part of the venture capital team. I'd like to invite Mr. Unawut, our head of venture builder, to share his thoughts on the importance of computer vision. A reminder as well, if you're interested in networking before the panel ends, feel free to discuss this in the pantry. There is also chicken wings and also pizza over there if you're feeling a bit hungry. So before we move on, please welcome Mr. Unawut.
Hi, so thank you everyone for joining our Moonshot meetup on computer vision. I think recently AI has been on the news, right? A lot of people are interested in it. A lot of use cases popping up, right? And I think most of the discussion or attention has been on text generation, ChatGPT, and large language model. And a lot of things are actually happening, and large language model is not the only field in AI, right? Computer vision is another area where there's a lot of potential, and a lot of people actually haven't put enough attention to it, right? A lot of people have been buying a lot of Tesla this year. They're in Thailand now. A lot of people know that it's AI, but I think not enough people know that it's actually driven by computer vision, right? And I think I'm not the expert in this area, but we have experts on our sessions tonight. So maybe just a bit of touch on SCB10X technology, disruptive technology investment and venture building arm of SCB10X. We always look for new projects to invest in, but also talented teams to help incubate and build the new next unicorn. So we are open to discuss if you have any ideas to bring to our VC team. We have representatives from VC team. We have representatives from venture builder team to talk about ideas as well. So open to talk more about AI, talk about computer vision and this, and last. So hope everyone enjoys the session and get something useful, get good insights out of this session. Thank you.
Thank you very much, Mr. Unawut. Now, let me introduce to you our esteemed guest for tonight. Please welcome Dr. Sanparit Murakatat, Senior Researcher at NECTEC. Please feel free to take a seat. and Dr. Itipan Metasate, CTO at C-Trust. And our final guest dialing in from the US, Dr. Andre Esteva, co-founder and CEO at Artera. We're honored to have you all here with us tonight. Before we dive in, can you kindly introduce yourselves and your work background, starting with perhaps Dr. Andre, Dr. Itipan, and then Dr. Sanparit. Andre, the floor is yours. We have a slight technical issue. Please allow our team to do a quick sound check real quick. Andre? Okay, can you try again? Test 1, 2, 3. Andre?
Testing 1, 2, 3.
You got that. Please proceed.
All right, fantastic. Well, thank you for having me. It's a real pleasure to be here. Thank you for organizing this great panel. Computer vision is one of the areas that is very exciting to me. I've been in the field for some time now. So just by way of introduction, Andre Esteva, co-founder and CEO of Artera. We are a company based out of San Francisco, California, that develops medical AI tests that personalize therapy for cancer patients. These are tests that look at images of patient tumors, as well as clinical data about patients, and they'll help tell your physician the best course of therapy and the likeliest outcomes if you're suffering from cancer. Before Artera, I was actually head of medical AI for Salesforce, where I led both commercial and research efforts in the medical AI space. Through an introduction from our CEO, Mark Benioff, I got to know my then research collaborator, now co-founder. We worked together for several years, and actually out of Salesforce, working jointly with UCSF, the University of California, San Francisco, we developed some fantastic computer vision-based tooling that would then spun out as the core founding IP of Artera. And these are tests that, in the space of prostate cancer at the time, we now have multiple tests, could prognosticate patient outcomes and predict response to therapy. And my formal training is in computer science, so I got my PhD at Stanford, working in the AI lab. And I did a lot of the early work in applying computer vision to medical diagnostics and demonstrating that it was as effective at clinicians at certain key tasks. For instance, this was back in the 2016, 2017 timeframe. We developed an app that could identify skin cancers on patients, and we actually showed that it was as effective as dermatologists. We went on to publish a Nature cover letter. We looked into commercializing the technology. It was a very exciting project, and that interest at the time in using computer vision for diagnostics over the years evolved into an interest in applying it for precision medicine, which is where my efforts and Artera's efforts are focused today.
Thank you very much, Dr. Andre. Dr. Itipan, can we quickly go through your work background and your history with computer vision?
Okay, thank you very much. I am Itipan Metasate, okay, and you can call me Tam. Okay, I am a CTO of C-Trust. Okay, actually the name Akumet, all right. Our company focused to build an AI for reading the document, especially in the financial document, such as invoice, receipt, PO, GR, and so on. And also, our AI have the special because we focus on understanding the document instead of just reading. Okay, and our target is to try to extract and understand the document or the content one by one, and also the relation between content in the document also. Okay, actually, in the challenge, we face with a human expectation, which quite higher than as we know before. Yeah, and we know that just accuracy of the AI is not enough for human, but we need to understand the expectation of a human also, but maybe not the accuracy can represent that one. Okay, and also in our company we have the big team of AI, around 15 person here, and also mainly focus of our company is just to make all the document flow to be automatically, and also we have some process to add human knowledge, human intelligence to make our AI improve every day. Yeah, that's all.
Thank you very much. Dr. Sanparit?
Hi. So, good evening, everyone. My name is Sanpalit Malekatat. You can call me Poon. I'm from NECTEC. NECTEC is a research center in Thailand, and we focus on computer and technology and electronics. And under NECTEC, we have several research groups. In AI research group, so it means that everyone in our group is working on AI, and we have 4 main teams in AI. We have team on image, that is my team. We have a team on speech processing, another team on language, on text understanding, another one on brainwave signals. So after I graduated, I started working at NECTEC. So everything I know is oriented by academic side. Okay, so our research topic is it varies a lot. It depends on what each researcher are interested in, or what sometimes there's people that come to talk with us and bring us a new research topic. That is also another possibility. So if you are interested to work with us, please.
Thank you very much. Pan, over to you with the questions.
Thank you, Chris, and thank you all the lovely speaker tonight. Without further ado, let's begin the session with basic questions to give the audience who may not familiar with computer vision an idea what we are going to talk tonight and what are our main topic will be look like. So starting with Dr. Sanparit, what is the definition of computer vision in your opinion? And why do you think the computer vision is important to us?
Okay, so computer vision is subfield of computer science, and it's about understanding the visual information. It means everything that we see, or everything that you scan, or you take pictures, or even sometimes like ultrasound images. So it's not a direct capture of image, but you get the visual information. And so it's interesting I think it's interesting for me, and I hope it's for you as well. It's interesting because there's a wide variety of applications. For example, in our lab, we work with document like CTrust works, and we work with CCTV camera, with the ultrasound images, with X-ray images, with sometimes generated images. So there's a lot of application, and I think it's possible to do business with that applications. For example, the document analysis, for example, and maybe other topics as well.
Thank you very much. And for Dr. Itipan, we just want to know kind of like the landscape in Thailand. Can you share a little bit on the current trends that you see in this field, especially in Thailand? What kind of developments recently that you have been seeing that up and coming in this field?
Okay, in Thailand, from now we have we are in the period of after COVID, right? And I think that the COVID situation make Thai people adopt with the technology easier, because every day we stay at home, right, and use our mobile phone, our maybe the banking, we have some authentication, face verification, so we're quite familiar with the AI service right now. From now, every bank have the face recognition and verify eKYC, yeah, and from before COVID, it's quite difficult for people to use, but from now everyone use it and familiar with that. Okay, and also from now on, some AI service, many kind of AI service you can see it very soon, such as in my company, the automation in the document automation. I think that every big company have the roadmap for this and invest a lot for to reduce the pain job inside the company. And also everyone touch closer, such as you have Tesla now sell in Thailand. and we familiar with some suggestion in the car, and also also in Thailand we still have Thai company that make AI also. Some company make some computer vision. Some company make NLP such as chatbot or something like that. This kind of product will closer to you easier, such as we have some groups of Thai NLP to try to make a Thai chat GPT. It's okay together with the global one, and also the video surveillance, the face recognition will be appear in your application more easier, because from now I think when you have many company make a KYC with face recognition. Okay, and you can see many kind of this in besides around you more and more, and also some come from Thai company also. Yep.
Thank you very much. To you, Dr. Andre, given the availability of open source today, open source model, and the convergence of AI models approaches, for example, you may have heard the transformer that have been used in large language model, and about the stable diffusion that used about the image generation. So kind of curious, how do you see this kind of development, and how do you build a moat around your business given this availability of open source models?
Generally speaking, technological advances are very, very rarely long-term defensible. Sometimes they're intermediate-term defensible in, let's say, the 3 to 5 year time frame. In the space of AI, where the field moves incredibly fast, and we all rely on open source data and models for either training, data sets, even APIs, if you're building on top of, let's say, OpenAI APIs or somewhere, there really isn't technological defensibility from having bigger and better models. There is always another group innovating on top of whatever is out there. Now, there can be defensibility in some cases in data. In certain domains, particularly those with proprietary or hard access data sets, you can create a moat around yourself by having access to data that lets you train models that no one else can. This is certainly true in domains like healthcare, for instance, in which it's very challenging to access patient data sets. It's very expensive. You need specialized connections and so forth. Certainly with large language models, if you're working strictly with open source data, there isn't a very clear moat. If you're working with computer vision, well, it depends on the tasks at hand, but also in general, it can be very, very difficult to build a moat around yourself. There are exceptions there, again, with access to data sets. So earlier today, the example of Tesla was brought around in autonomous driving, which today is largely based off of computer vision, actually. There is some 3D vision there with LiDAR and so forth, but most of it is based off of two-dimensional computer vision. And in situations like that, where you need computer vision to be exceedingly accurate in the 99.999% accurate regime, because if you're wrong about a prediction, you might run a pedestrian over, then having an incredibly large data set that is proprietary can be reasonably defensible. But in the long term, companies, especially AI companies, would really benefit from building moats other than technological and data moats around themselves. Branding is a very strong moat. Commercial footprints with customers that have long-term contracts can be quite defensible. And if you can build an ecosystem on top of yourself, for instance, how OpenAI is building an ecosystem of startups that rely on their APIs, or for instance, how Salesforce built an ecosystem of apps that rely on their platform. This is very defensible, not only because there's many players in the ecosystem that rely on you, but because then you can sell bundles to customers that include a number of different offerings, and in some sense, you have herd defensibility.
Yeah, totally agree on Dr. Andre answers. And moving on to the next questions, as computer vision is a rapidly evolving field with new research and breakthroughs happening in kind of like almost every year, and the question is, what are some of the biggest challenge that you see that computer vision is facing today, and how do you see these challenges being addressed in the next couple of years? Let's start with Dr. Itipan.
Okay, thank you. Okay, for today, normally computer vision, the main barrier is just computing, the first one, and sorry, the main barrier, right?
So
Okay.
the biggest challenges in computer vision.
The first one is to manage the computing power of this one, because normally in computer vision we need a lot of computing power, GPU and CPU. Okay, but for now, it's a good sign that the new algorithm we can apply in, and also the hardware is have some more advance about that, so we can have some new application over there. And also the one of the big challenge is the application need to touch with the human expectation, because in many ways, such as computer vision in the automation car, the goal is just is to drive instead of human. Is quite a really long target, right? And this is the challenge, the big challenge of the technology, that we need to make it to the same level as human done. Okay, and with this one is take a lot of technology inside and take times to develop, and also main goal is to actually in this current status, the AI is just only to help people to work or to do some activity more easier, but not replace the human. I think this is the biggest challenge right now. Yeah.
Dr. Andre, do you want to go next?
When it comes to thinking about the biggest challenges facing computer vision today and how they're being addressed, it's actually interesting to take a look at the history of computer vision and many of the challenges that it has already solved. So in computer vision, many fundamental tasks, object classification and detection and segmentation, have largely been solved in recent years. And where the field continues to innovate in really exciting ways is around topics today, for instance, in generative AI, around image and video generation. There we've certainly seen a boom in the last 12 months, but also in areas that relate to being able to learn effectively from tons of data and very few annotations. Leveraging advances in unsupervised and self-supervised learning to power what's called few-shot learning, where you have very few annotations to learn from, but you might have a massive corpus of unannotated images that you can leverage. Those areas have matured very nicely in recent years and continue to do so. You know, a 3-year-old, a 4-year-old, you can show them one example of a coffee cup, for instance, and they can distinguish a coffee cup from other glasses that they've seen in the past. Machines still struggle in some sense with these very basic tasks, or when objects are occluded, or in fully understanding everything that's happening in a scene. And so, whereas in computer vision, we have certainly solved a number of, call them low to mid-level tasks, from segmentation to what are we looking at. There are still a number of high-level tasks that humans do instantaneously without even thinking about it, like total scene understanding, that machines actually still really struggle with. Additionally, there's a number of fields in AI that, it's beyond computer vision. There's NLP and RL and speech and so forth, that will, jointly all face the challenge of becoming more and more multimodal. So essentially being able to learn jointly from, let's say, images and text, and use natural language to describe images, and take images and describe them in natural language and so forth. As the tasks in singular domains are solved, as computer vision alone matures, as NLP alone matures, there's going to be more and more tasks at the intersection of these fields. When we think about building artificial generalized intelligence, human-like intelligences, it's very helpful to think about ourselves and how we go about our daily lives and how we interact with the world. So for instance, if we were able to, one of the big challenges in facing, say, the field of reinforcement learning is being able to train an RL agent that can navigate an environment both by reasoning about what it sees and reasoning about what it reads, and taking those two data streams and conflict resolutioning them, excuse me. And so in addition to higher level tasks in computer vision and learning from smaller and smaller pieces of data, the intersection of fields continues to be a big challenge.
So Dr. Andre, I just want to get your viewpoint as well. Given the local context of the US and how you're trying to also striving to become the AI superhouse, have you been presented with any challenges, especially on the hardware front?
Well, it depends on what you're doing. Let's say that you're building autonomous driving. Hardware can absolutely be a challenge. You need to build a fleet of cars, put them out on the roads, and then collect data from that fleet of cars before you can really train the kinds of models that would be effective in production. And in general, whenever it comes to, say, the differences between AI in research and AI in the commercial space, you have to build the system in the commercial space that will be deployed, collect data with that system, train models with the data of that system, and then deploy that model into that system. And so when it comes to thinking about hardware, whenever a hardware system is a piece of a real world deployment, there can be real challenges there. Now, if hardware is purely in the cloud, let's say that you're building a software solution and all you need access to is a cloud. Pick your favorite cloud, be it AWS or Microsoft or Google. Hardware is actually absolutely not going to be a challenge. It's very straightforward to spin up GPUs, TPUs, and train models at scale. So it really depends on the use case.
Yeah, thank you for sharing your viewpoints. Over to you, Dr. Sanparvit. Can you share some of the challenges that face computer vision today, and perhaps your role as a leading researcher for the leading government institute? Perhaps share your opinions on that as well.
Okay, so the problem with hardware, both Dr. Tam and Dr. Andre talk about it. In our lab, we have people that come to talk with a new research topic, for example, to analyze CCTV camera from all around Bangkok. So the task is quite easy. You get some video streaming and then you detect vehicle and then you track them. The problem is the number. We have like more than 10,000 camera in Bangkok. So how many GPU cards do we need to buy in order to process that? That is a bottleneck. We don't know how to solve it. Some people propose to build an embedded board that can process the video images on the pole before sending the result back. But then if we need to buy 10,000 board for that, it's not an option as well. So it's still open question about how should we solve this kind of problem. So for now, we just process some videos, some video from some camera. We manually pick it, that we say that, okay, this view is enough for us to track the vehicle. So we use this view as an example. But for large scale deployment, I think the hardware will still be the problem in practice. Another problem is about the data. Earlier you mentioned the large language model, and we all know that large language model requires very large training corpus. And for example, in Thai language, one of the public data set that is very large, I think almost 30% of the text inside come from gambling and porn. So if you want to build large language model on that, I don't think it's a good choice. So model like ChatGPT, they also train on some books data. So we still need those kind of data. It's quite difficult because now you need to talk to the publisher that have the rights on the text so that you can use them. So it's still, I don't know, we have a lot of resource, but it's just a limitation in terms of how can we use them properly. And okay, and about data, Dr. Itipan talked about face recognition. So every bank use KYC, right? Use face verification system. And I don't think they develop it by themselves. They just bought from some company. And each one will come with their claim accuracy that says that, okay, for our system, we have 0 false accept rate. It means that you cannot disguise as other person and let in. And how do we know it's correct? We don't know that. If we really want to know that, we need a large corpus of face images in order to test. And with today's laws about PDPA, it's quite difficult to have a large corpus of face images to test. So we have a real problem with data. Yes.
So a lot of Thai companies, especially AIs, have problems accessing large abundance amount of data. Is there, I would say, a government-led consortium among private companies that allows data sharing between entities so that we can have better AI? I'm not sure, Dr. Itipan, given your role working with a lot of corporates, has there been any such initiatives moving forward? Have you seen any emergence of this?
Yeah. Actually, in Thailand, we have the association of the AI company. Yeah, we call AI EAT. And also, it's a group of company that to make AI by their own, not just only buy from outside. Yeah, and we make our own service. And also inside this, the data still the problem. Okay, but anyway, we try with this association. We have some activity to help each other, and also we have some connection with some association of AI in Thailand, such as AIAT, such as is about the academic association, and also in some organization of government, such as DIPA, NIA, or yeah. This one we work together and try to make some share resource and also funding with for AI community. Yeah.
Thank you very much for the very insightful responses. Now jumping into the technology and application of computer vision. So with the rapid trend of computer vision developments recently, in your opinion, what are some of the most promising new technologies and application in the computer vision that we have seen today? And in terms of technologies and techniques that you see very promising, what kind of application that can be built on top of that? Let's start with maybe Dr. Andre.
Absolutely. I think this is a very exciting question. The field has grown incredibly fast in recent years. So certainly the area of generative, when it comes to thinking about promising technologies, both from an algorithmic development perspective, but also application domains. There's several that comes to mind. Certainly generative AI, applied to computer vision, generating images, generating videos. And being able to do so from simple textual descriptions is very exciting. I think multimodal computer vision, where you're fusing some kind of an image or a video stream with either a language or a speech or tabular data or something else, is also very exciting. It allows you to do things such as use natural language descriptors to attend over images and ground the image understanding for better prediction tasks, for better generation tasks. Self-supervised learning and unsupervised learning, where you're actually successfully learning some features from images and videos that can later be turned into supervised models with very, very little data, thinking of few-shot learning, is also very promising as it matured substantially in recent years, especially with the advent of better training protocols. We use these very successfully at Artera in the healthcare setting. We've been able to develop multimodal computer vision that looks at images of patient tumors. This is from digital pathology. They also ingest clinical data about patients, such as, how old is the patient, what's the stage of the tumor, and so forth. And it actually enables physicians to predict what is going to happen to a patient in 10 years' time, in 15 years' time, the kinds of tasks that humans cannot possibly hope to do well, because it requires this sort of fusion of multiple data streams. And a few years ago, this technology would not have been at our disposal. But additionally, there's a number of other application areas, say around better video search. And this taps into questions about security, but for instance, surveillance. You can now imagine a fleet of cameras around the city powering law enforcement to be able to search in real time in natural language. Is anyone being harmed? And deploy that query across potentially thousands of cameras with real-time video and get back a triaged set of images and real-time video of crime that might be happening in that moment. The technology here at this intersection is incredibly powerful.
And Samparit, also can you add about the key industry that you think they maybe have a beneficiary of using the computer vision application as well?
So the city management, like the monitoring crime, like Dr. Andres said, I think it can benefit from computer vision. One thing you should know is that the problem with image search, the problem with search in general, in order to perform search, you will need to index the data first, right? So that you can search quickly. So 20 years ago, when we talk about image search, it means that you will need to index each image by image features. And then when you search, you will need to provide some image query so that we can compare the features to say that if this is the same image or not. But I think in recent year, like maybe 3 years ago, we had a new model from OpenAI again. It's called Clip, and it's two models. In fact, it's a model that process image, another one that process text, and then if the text and image match, you get the same features. You get similar features, and from that, what you can do is that now you have a video, you can index them with image features. And when you want to search something, you just extract text features from the query and then you search. And that is new thing that 20 years ago we cannot do it. So I think it's a quite interesting idea today. So I don't know if you can make business out of this thing or not, but I hope you can.
So on the context of smart city solutions as well, I think Bangkok has been a prominent use case when it comes to detecting if you drive fast, because a license plate will be taking a snapshot to your house. But how far are we from facial detection?
If we talk about detection, it's easy. I think problem is solved today. The problem is, in fact, the recognition and verification task. Verification means I come here, I claim that my name is Samparit, and then the system load my model and then compare against me. So it works when we enroll in the system. But if you are unknown, some stranger guys that walk in SCB 10X, but you cannot verify them. So there will be problem. And about recognition means that the system know who you are, but again, it needs to enroll your model first. And so you can just do it on your company, but I don't think you can do it in large scale, like city size to cover everyone. That will be difficult.
Dr. Itipan, anything to add?
Okay. Actually, for the technique of computer vision today, if you are in the academic topic, right? These few years have one keyword appear, the keyword of vision transformer. Yeah. Okay. And I think it's quite very interesting one because Normally, this technique is we use for NLP only. But for now, we have some attempt to apply this idea to the computer vision, and with this way, many times that we find some breakthrough in some application inside. And also, as a classic problem about the lack of data, yeah, so there are some techniques of transfer learning, such as few shot, zero shot, one shot, a lot of shot in the paper. Yeah, so with this one, I think is a like a game changer that to make us to build the model easier when we don't have the data enough, and but we have some pre-trained model or some pre-knowledge. Yeah, and this way we can reduce the time and improve the performance of everyone to do this kind of job. Yeah.
Thank you very much. Moving on to next question. How can we design computer vision systems that are perceptive and user-friendly, and that also allow for natural interaction between human and machine? Start with Dr. Samphat.
Okay, so I think we are on the right direction today. That is to combine text with image. So because it provides for user a more natural way to express what they need and what they want. Before this, when you for example, if you ask someone to draw a face, you have to ask how big is his eye, how big is his nose, etc. Right now, you can just say that I want the face that look like some people, and it works. So I think we are on the right direction of having a very easy, user-friendly interaction with image processing applications. What is the other part?
So the other part is, and that system also allow for the natural interaction between human and machines. So anything on the view that we how to achieve on that design?
To achieve that, you need to understand text. And in order to do that, you need, I don't know, maybe very large corpus of different, for example, in Thailand, when you are in northern parts or in southern parts, you talk with different dialects. So if you want the system to be accessible for everyone, you need to understand the local dialects. Here is, for example, one of the problems that need to be overcome.
Thank you. And Dr. Itipan, any
Okay, for me, I think that for AI today, we can achieve the 100% of accuracy for sure. Okay, within these 5 years is close to 100, but not 100. But we need to think about that. The first one, the user need to do everything easier, and we need to design everything, the interaction between the technology and the human, with the same way that they work, but with less job to do, something like that. And also the main key, actually we have one keyword is human in the loop. When we apply AI, we need to design how human transfer their intelligence or their knowledge to the AI. This is the main improvement task that make our engine or our product better every day. Yeah, this is a key, because if you cannot transfer intelligence from human to AI, it means that AI never be improved, right? And it will die very soon. So I think this is a key of design between human and computer right now.
And Dr. Andre, to you, this question.
I think it's a very interesting question. How can we design computer vision systems that are both perceptive and user-friendly? I agree 100% that the intersection of computer vision and natural language will greatly support this. Having machines describe what they see in natural language, enabling humans to reply also in natural language, will really ease the two sides working together. and it'll make a lot of otherwise very complicated computer tasks pretty straightforward. You can query databases in natural language, you can have machines reply, and so forth. We see this intersection start to rise with DALL-E and with other ChatGPT functionalities. But in addition to this intersection, I think that having higher and higher abilities in machines to understand natural human behavior and respond to it will be really important. Think about the space of robotics, whether you're thinking about an autonomous car or some robotic delivery, or perhaps a humanoid robot in your home. These are not applications that are decades away, but potentially years away. Human behavior is not fully rational. And so if we can empower machines to better understand human behavior and predict human behavior, whether it's a child that is about to, out of nowhere, run across a street, or an elder that is about to fall, and whatever the case might be, this sort of visual reasoning and short-term prognostication of the future, I think will allow for a much more natural interaction between humans and machines in our environment, instead of expecting machines to act the way that historically they have, where they have specific rails, like a train that can only go on certain rails. For machines to interact with humans, they have to understand us at a much deeper level than they currently do.
Yeah, thank you very much. Moving on to the next question. Looking ahead to the next 10, 20 years, I believe we will see continued growth in the development in this field, and also a new application and use case that coming up in the next 10 to 20 years. But given this rapid pace of change, what do you think are some of the most important ways in which that computer vision will shape the society in the coming years, and how can we prepare this change? Let's start with Dr. Ipipan.
Okay. Actually, from this, okay, you can, as I said before, that there's a lot of applications that have AI inside, and it's close to us every day. Okay, and from now, many applications we try to add some AI into the device also, such as CCTV. From now, we have the CCTV that have the edge technology inside. So we add some AI model inside to detect and send some information of yourself, of everyone that pass to the server. Okay, and know what happened in the building, in the street, or when in the city, right? And we in Thailand you can see some example of this increase every day, such as on the road. From now, we have some CCTV camera, right? And they have some speed detection with the camera with AI inside also. Yeah. So from this, we finally can accept as the AI as some environment that we touch every day, and also at the end of our 5 years, we will use it every day. Such as you come here, you use Google Map to lead you to this building, right? And I think somebody cannot go to some place without Google Map. Cannot go in. We need Google Map in everyday transportation, right? Something like that. So the application is close to us more and more. Okay, and we accept the new applications, such as, okay, maybe every day we can use face recognition, fingerprint scan, and every day maybe the virtual assistant can be on your desk to talk with you every day, to suggest what you need to do and what you want, and deliver some solution for you and all the time. Yeah, something like that.
And I just wanted to ask as well, in the context of OCR, where it's more prevalent among corporate innovation and digitization in-house as well, that process is no longer outsourced to an emerging country where there's people deciphering an invoice document, for example. How much has this impacted employment in the future, and how much has this created jobs for people who leverage OCR well?
Okay, I think for now, this year, many big companies try to apply AI technology, AI OCR in the company, mainly not for reduce the employment, but to help the people in the company to work easier and have a good life. Okay, they change the duty of the employee to change from key in into just check and give the opinion. Yeah, so they can work smarter. So the trend is to the employment should be better because for now I think every company face the same problem because we cannot hire the staff for just key the document, right? Because they do not grow in the career path, they do not have the good life enough for today. Yeah, and this technology will help us in this way.
Over to you, Dr. Andre. What do you think about the computer vision in next 10 to 20 years that will shape our society?
I think our society in 20 years will look fundamentally different than it looks today. I think in 20 years, we are very likely to have AGI, artificial generalized intelligence, which is the new term. It's what artificial intelligence used to mean, an actual intelligence, a consciousness in the machine in some sense, or at least something completely indistinguishable from it. And when you think about how computer vision will impact that and influence that, I also find it useful to look to the past. So, hundreds of millions of years ago, when eyes first evolved in organisms, they led to what was called the Cambrian explosion. It was a massive speciation where the planet went from having some whatever number of species to orders and orders of magnitude more. Because with the ability to see, organisms could interact in a completely fundamentally different way with their environments. They were no longer constrained to what they could feel, but much, they could see, they could go much further distances, interact, as predation changed, everything changed for species. And interestingly, and it's actually Faith Lee at Stanford that gets credit for this analogy, we started to see this happen as well in computer vision as a subset of AI. So in the 2012 to 2014 timeframe, when deep learning and computational power and large-scale data sets started to converge, computer vision underwent a renaissance in the 2014 to 2018 timeframe, which has since continued. Those were when mid-level tasks really got solved, like detection and classification and segmentation and so forth, which led, in some analogical sense, to a speciation, a Cambrian explosion of applications. And you saw hundreds, thousands of startups, appear almost overnight that were applying these tasks in computer vision to any number of domains. And I think that trend will continue and be augmented and enhanced by what we've seen in the last years, last 2 to 3 years, really, the growth there in large language models and NLP. I think that a similar kind of coming of age will occur in other areas of AI, like reinforcement learning. Today reinforcement learning has the remarkable things for us, from predict protein structures to playing Go better than world masters and so on and so forth. And as these fields continue to mature, and as the intersection of these fields continue to mature, I think computer vision will really be one of the most fundamental ways in which AGI goes from being really good at responding through textual interfaces such as ChatGPT to actually being able to interact with us in a real world setting. Computer vision is what's going to allow robots to actually interact with us. It's what currently allows autonomous driving to function to any degree. It's what's going to make cities almost come alive with the perception of what's happening within them.
And Dr. Andre, given that you've probably interacted with thousands of medical professionals, what are their thoughts about their careers moving forward? Will they be AI dependent, or are they concerned about the dystopian future of AI?
In some sense, that depends on who you speak with. Folks that are earlier in their careers are very excited by the technology. Folks that are later in their careers, it's a split opinion. The consensus seems to be that, and it was Kurt Langlotz at Stanford that first coined this term, physicians with AI will replace physicians without AI. The AI will not replace the physician, but it will greatly augment them. We see that through diagnostic tasks that AI can do with superior performance to physicians, such that humans plus computers do better than either alone. We certainly see that in our work. We see that today ChatGPT, especially GPT-4, can pass a number of medical licensing exams, which are more than multiple choice. It's actual text-based replies and it's dialogue and so forth. They can pass them in high percentiles relative to clinicians, which means that AI just became a co-pilot for the medical profession, or has the potential to become it. Of course, there's many barriers to adoption, and there's security and privacy and regulations to navigate through. Certainly, however, the technology is there now. So it's a very exciting time. I think there is a set of questions around how it'll get integrated into workflow, which some clinicians are very excited about and others are less excited about.
Thank you very much. Dr. Saparit, your closing thoughts about how society will change in the next 20 years.
I think it's difficult to imagine. For example, 3 years ago, I think nobody knows about diffusion model. Only few researchers in computer vision. Last year, I think everyone use stable diffusion to generate things. And it does create new jobs. If you look at the Facebook pages, they have lots of pages about AI artists, and they share prompt about how to use the prompt to generate the image they like. So the situation changed very quick. And I think that the adoption of AI technology is also quick. Lots of people now, it's okay that you write things with ChatGPT as long as you can check the validity and say that it's correct or incorrect. You can use it, for example. Or in medical domain, for example. I work with a doctor from Chulalongkorn University, and we start working together like 6 years ago. And 6 years ago, they say that, okay, in the conference, medical conference, there are like 5 or 10% of work on AI system. And then the next year, it raised to 20 and more percent. And then it increased very quick. And so the medical domain, the doctors also accept the black box, the AI as a black box, as long as they know how to, if they understand the limitation of the model, how they suggest in which condition it make the good prediction, in which condition it make the wrong prediction, or how it can be used. For example, the doctors that work with me, they work on abdominal ultrasound image. And ultrasound problem is operator dependent because it depends on how you put the probe. You get different image. And so there are some standard view that is recommended that you need to go through in order to see the full, but not everyone do that. So we can make a system that analyze the view of the ultrasound images and then notify when the operator miss some view, for example. So this kind of AI, the doctor like it because it just help them in their work. Right? I think that in the future, lots of people will also accept the works that is co-pilot between human and AI.
Yeah, that is very interesting, and thank you for sharing your thought on the future of our society with advanced computer vision and AI, obviously. And for our last question for tonight, I would like to touch a little bit on ethics. So, in your opinion, what are some of the ethical considerations when using computer vision? Like, giving you an example, With the growth of use of surveillance cameras and the facial recognition systems in the public spaces, how can we balance between the need of security and the individual rights? Start with Dr. Samparit.
I think it's very difficult to have a good balance. So, but okay, it depends on. I think it's depend on the government that decide that okay how to trade off between security and privacy. Maybe it will not be an easy dialogue to find the right trade off. Maybe in the next 10 years we still haven't found the common ground to balance between privacy and security. But other form of ethics is that I believe that one of the problem of people that use AI is that those people that use AI they didn't know about the limitation of the AI. For example, we believe that ChatGPT, when we ask something, it seems like it understands what you say and it answers. But in fact, it just produces next word prediction. So if you know that, then you will not take the message as serious as other people. Okay, so I believe that those people that use AI, they need some AI literacy, some background on AI in order to get a fully capacity of the system and in safety.
And how are researchers in general thinking about this information and how end users like us are receiving the most accurate and most truthful information available?
Oh, quite difficult. I said it's difficult because when you want to buy something, you just ask for the main features like the accuracy or things like that, and then you decide. But if the salesperson tell you about how they perform the test on how many people and things like that, I think that you lost interest in the product. So maybe maybe we need someone to digest those information for us. So in form of things that is understandable for large public, so that we can agree with the claim of the accuracy, things like that.
So, for example, in the context of computer vision, the rise of deepfakes has been rapid. The context of people's face swapping with one another for committing crimes they did not commit also increased as well. Fraud detection also increased. Not sure how researchers are now thinking about some of the abuses users are committing intentionally.
There will always be abuse when it comes to people. Computer vision is just a tool that they use to abuse. But if you consider the scam person that sent this scam email, they didn't use any high-tech technology in order to fool you, right? So I think that in terms of computer vision, the deepfake things will be more and more difficult to detect. In the end, I think that you need to believe in the source of the information as well, that the information come from the reliable source or not. And if you can trace back to the source like that, maybe you can get better confidence on the data.
Dr. Itipan, to you this question.
Okay, about the ethic. Okay, normally the ethic depend on many development parameters such as area, time, situation. Okay, such as you are in the normal. Okay, if someone want to capture you in the camera, so we need to ask you, right? But in some area, they need just only tell you if you want to come to this area, you need to accept something like that. So it depends on some situation and culture also. I think for ethic from now is not. We just start. Okay, we talk about ethic of AI just only a few years ago, and from now we just a guideline only. after this, I think that still have some standard of working or standard of how to do, such as the way that if we apply the computer vision in the cameras, and we need security in some level, and we have the way to consent, like a standard practice for the technology to use this way to apply. Yeah, but for now it's still not clear about that, because we don't know how effective about the law, how effective about the social thinking about that. Yeah, and it's more clearer in a few years after this. From now, the guideline of the law is open right now. Yeah, and also the main thing that when we apply the AI is the list of the situation. Also, if that list touch the human rights or touch the safety of the human, I think it's automatically have some situation that some technology can be overcome, can be forced to use for the safety reason or the security reason, something like that. Yeah, and but anyway, we as everyone said, in the future we can accept the technology easier. So the way of consent will be as a standard also for us so maybe it can be possible that we consent every day or every time we go inside the building or something like that. Yeah, it's like an automatically activity that we can use every day.
And Dr. Andre, your closing thought on ethics?
I think ethics, when it comes to computer vision and more broadly AI, are key. You brought up the question of surveillance and facial recognition systems and public faces and deep fakes and so forth, and how do we balance security with individual rights. Security is critical. Data privacy is also critical. I think that thinking about how you build the right constructs to ensure these things will fall largely on both the organizations that are developing the tools, but also on the policies in the countries that are allowing these sorts of tools to be deployed. Going back to our example of having a city almost come alive through surveillance systems and being able to very rapidly in real time without indexing search for someone committing a crime means that on the one hand, law enforcement could be equipped with real-time criminal information. On the other hand, governments and corporations could very easily abuse this kind of power. So I think we're going to have to develop a much more robust set of policies and guidelines and so forth that help to monitor and potentially regulate the development and deployment of AI technologies. And it's very important that these policies kind of be refreshed. I'll give you a very specific example. So in healthcare in the United States, we have HIPAA, which is a set of policies that is intended to protect patient privacy. However, they were developed in an era before computers. And in that era, medical privacy looked like, documents were kept in paper files, in office buildings, so a lot of HIPAA is in many ways out of date. You need to maintain things behind locked doors. You need to make sure that there is physical distance between one patient in a clinician's queue and the next patient. Many of that does not make sense in a digital world where the data is all online. It's potentially indexable and searchable and so on and so forth. And so to have, I think, effective security and really good ethical considerations, it's important that policies catch up with the latest in technology. And often those are two things that are very much out of sync.
Thank you very much for sharing your thoughts and sharing your expertise with us tonight. Now, we would like to open the floor to the audience here and also in online. You can comment in our channel in the platform as well, and the audience here. If you have any questions to ask our speaker, you can feel free to raise your hand and ask the questions now. Please, don't be shy.
And
Or
of course,
maybe-
if you're feeling a bit shy, you can ask after the talk.
Yes, definitely. All right, then, because
Yeah.
any questions?
Well, it's a wrap for us today. I'd like to extend our heartfelt gratitude to our guest speakers for their very deeply valuable insights and to our audience as well for their active participation. So now please enjoy the networking session and get to know your fellow computer vision enthusiasts. Have a great evening. Again, so beer, chicken, and pizza is over there by the corner. It's within reach now. So if you're feeling a bit hungry, feel free to grab a drink or two before you head off. Thank you very much, Andre. Thank you very much, Dr. Itipan as well. Thank you for all our guests. Thank you, our guest speakers.
Thank you. Thank you very much.
Thank you.
Thank you.